So good morning, this is a report of the group 2, so lighting design and principle, a guide for a pleasant lighting atmosphere. So what is light? So light is a light of part of the electronic magnetic spectrum visible to a human eye perceiving different colors depending on the intensity. So there are 7 colors, which is violet, blue, green, yellow, and orange. Yellow, orange, and red. So the high intensity is red. So this is common to na makita nato sa palibot or especially in the general highways. Kay kani mga light isa common jud kay yellow, orange and red. Kay high intensity na maka-attract sa atong mga mata. Then the importance of light. In that architectural settings, light is available to illuminate and add a comfortability and draws attention to certain areas, bring out the emotion and the way of architecture perceived, which is the mind and important to take into consideration energy consumption and functionality. And also the light can also change the mood within the room. A room of bright and a clear room calms the mind and gives us a focus and light focus on a certain areas give is a highlight on certain scenes. And there are a few biological effects that light can give us. Support the origin dream, aims and tensions for our eyes and depending on source of views. So ang light are different many ways na have a advantage and disadvantage. So ang advantage kay gamit siya sa gabi nga kuan most especially in a company kay kung walay light so asa man magkuha ng mga employment and also sa mga nasa mga general highways mga kalsada kung walay light so mo nang has a common na big factor nga dako gid siya disadvantage dako gid siya advantage so ang disadvantage kay pero less than jud ang disadvantage kay light is a more importance man jud sa ato ang panahon, especially for the 21st century. So, and there are presentation guides, so topics that be covered. So, the first is the design approach. Second is computation and luminance for a single point source, average and luminance levels in a work plane, calculating average and luminance levels, and the lastly is the benefits of an energy efficient lighting. So, there are nine topics that were covered for our lighting design principles. So kani mga topics kay dako jud ni makatabang or magpasabot nga ngano ang light is importante medyo sa atong lives karon nga panahon or karon nga generation. So what are the problem do you want to solve? So these are common factor nga nakita nato nga there are advantage and disadvantage. So ako mga ka-group kay mo sila mo present sa topics of our coverage. So thank you and have a nice day.
Basic design approach. Proper design of a lighting installation requires use of two calculation procedures: computing illuminance from a point source and computing average illuminance levels. Calculation of illuminance at specific points in a lighting installation is done to evaluate lighting uniformity, especially when using luminaires where maximum spacing recommendations are not supplied or where task lighting levels must be confirmed. A light source should be able to provide adequate lighting enough to brighten a place to increase visibility without being nuisance. Areas should be illuminated enough to that walls and floor are clearly visible. Different rooms will have different types of lighting with different positioning and distribution but providing the same function. The level light within a room is called luminance. Luminance and illuminance. A kitchen would benefit to having lights inside and under cabinets and a large downlight in the preparation area. An office room would need ambient light so as to not cause glaring to a screen and to calm the eyes. There are 5 luminar types with different distribution. 1. Direct, 90% to 100% light directed downwards. 2. Indirect, 905 to 100% is directed to ceilings and walls. 3. Semi-direct, 60% to 90% is directed downwards with rest directed upwards. 4. General diffuse, equal portions of light are directed upwards and downwards. Highlighting, 5. Highlighting, projection of beam and focus to one area. Consider the positioning of the light that it may properly give off light without distracting or causing shadows. There should be downlight sources for task areas such as tables as opposed to relying on rooms. Ambient lighting. A room's main light source has the tendency to be useless as it gets shadowed by people.
So the second principle is we have the computation for illuminance from a single point source. So generally speaking, computing the illuminance from a point is very complex, and usually this involves computer analysis. However, the thought of the analysis is founded on the principle that the intensity of light traveling away from the source decreases, so it decreases as it goes further from the source. So shown here is the inverse square law. This states that the illuminance of the point, which is E, is inversely proportional to the square of the distance. That is the distance from the source and the reference point. And here, I, which is the luminous intensity, is directly proportional to E, or the illuminance. So, luminous intensity is like the kahayagan sa light. So, since illuminance decreases rapidly as the source is further from the object or the plane that is being lighted or illuminated, this law suggests that we should put our sources closer to a task as possible. So, this applies in our daily activities. This is the reason we use like table lamps or study lamps when we write notes, we study, as we do our plates. In works that requires high illumination, we use task lighting. So, like the study lamp, we use task lighting rather than ambient lighting because this kind of work requires focus and good lighting is very important. So, that is how we compute for illuminance. E equals I, which is luminous intensity over the square of the distance. So, that is all for principle 2.
I'm going to talk about average illuminance levels at the work plane. The designer is frequently interested in achieving a specific level of illumination at a reference work plane throughout the room or space. For example, 15 FC may be acceptable on the floor of a lobby, 30 FC on a table in a conference room, or 75 FC on a tables in a drafting production area. This target illumination is actually the average illuminance at the reference work plane. The work plane is an area, usually horizontally positioned, at which work is performed and on which the illuminant is specified and measured.
Calculating average illuminance levels. To get the average illuminance levels, we can use a process called the zonal cavity method. This method works best on symmetric light distributions and uses a principle where foot candles at the work plane are equal to flux over work plane. There are 4 basic steps to calculation of illuminance level. First is to determine the cavity ratio, whose formula can be seen here. Multiplying 5 mH, which is distance between luminary planes and reference work plane, with L plus width, all over length times width. Another formula could be 2.5 mH times perimeter over area. Second would be to determine cavity reflectances, which would differ in percentage depending on the overall color of the room. Here you can see the formula for the cavity ratio. Here are the different coefficient of utilizations, and here is a visual representation of a room cavity. Luminaire spacing. Once a number of luminaires for uniform lighting is determined, they must be arranged in such a way that it casts light evenly on all directions. Different luminary types will have different casting directions, and all need to be taken into consideration before implementing them into the room. Another key thing would be spacing. If you look at the image on the right, there are two ceilings. These give off the same amount of light, but notice how one of the ceilings only requires 4 light sources. This is because the design on the right maximizes the potential of each source and spreads them out accordingly.
Spacing criterion. The spacing criterion ratio is an approximate maximum spacing to mounting height ratio required to ensure uniform illumination on the work plane. It is used as a conservative guide to determine maximum center-to-center luminaire spacing. It takes into account the direct component of illumination only and ignores the indirect component of light, which can contribute significantly to the uniformity. However, it is used within its limits. The spacing criterion can be a valuable design tool. So, every manufacturer provides a maximum spacing criterion, which is a ratio to help determine the maximum distance you can put between each light. So, to use the spacing criterion, multiply the mounting height by the spacing criteria number to find the luminaire spacing. So, you must multiply the spacing criteria to the mounting height, which is in feet or in meters, in order to get the luminaire spacing.
Next is the power density and power allowance. Unit power density (UPD) of a lighting installation is the power consumed for illumination watts divided by the area served by the lighting installation. It is expressed in area multiplied by watts per square meter. It is frequently used as a measure of installed building lighting efficiency. A lower UPD indicates a higher efficiency. Typical power densities in new lighting installations are as follows. 1. General fluorescent lighting systems, such as in an office building, have lighting loads of 1.5 to 2.0 watts per square foot. Number 2. A fluorescent lighting system with both task and ambient lighting has a lighting load of 1.2 to 4.0 watts per square foot. And lastly, an HID lighting system has a load of 1.0 to 2.0 watts per square foot. Now let's move on to the next topic, which is reducing the cooling load. The intent behind the power allowance standard is to stimulate use of more efficient lighting, but it also reduces a building's cooling load by reducing waste heat. All of the energy consumed by lighting is converted directly as heat into the space. Therefore, any improvement of light system efficiency reduces the amount of heat that must be removed by the air cooling system. This results in an air cooling energy savings during the operation of the building. In new construction, an energy-efficient lighting design can result in significant savings in the installed and operation cost of cooling systems. A rough rule of thumb is that every 2.0 to 3.0 kilowatts of lighting load requires an additional kilowatts of cooling. Therefore, in theory, every 1 kilowatts reduction in lighting often results in a 1.3 to 1.5 kilowatts decrease in total electrical energy consumption. That's all. Thank you.
Benefits of energy-efficient lighting. Commercial, institutional, and industrial lighting, for examples for schools, industries, stores, offices, and warehouses, represents from 80 to 90% of the total lighting electricity consumption. If energy-efficient lighting were used in all places that it was profitable, the electricity required for lighting would be cut by at least 50%. Frequently, a blended lighting installation with a mix of efficient lighting, for example HID, can be used to provide efficient ambient lighting and combine with lamps for good color retention, for example incandescent, to provide for a more efficient system. So in summary, The main benefits of energy-efficient lighting include reduced electricity demand, dramatic energy and maintenance savings, and a lower operating cost. What is the most energy-efficient lighting? Another ideal light source to use would be LED, as they save the most energy while still managing to provide a strong and consistent output. They also have the longest lifespan out of the other sources, such as fluorescent and incandescent. So this concludes that LEDs are the most efficient, longest lasting, and most affordable energy efficient bulbs available. Compact fluorescent or CFLs are much more efficient than incandescent bulbs, but they are not nearly as efficient as LEDs.